We started lesson 5, graphing proportional relationships, yesterday. And when we started it yesterday, we looked at understanding just yesterday what a proportional relationship looked like on a graph. And we understood, I'm going to scroll down here, that when you are looking at a graph, if you're determining if it's proportional on the graph, I underlined right here, the graph has to be a straight line through the origin, which is 0, 0. Origin is that original point in the center of a coordinate plane at 0, 0. So if the graph has a straight line and it goes through the origin, it is considered proportional. So we walked through a couple of examples like that. We did example number 1 and letter A on page 46 yesterday. We also looked a little bit further, and we tried a couple more. So I'm just scrolling down to where those were. You actually tried one at number 2 in the independent practice, and that was on page 49. And you were able to check your work after you tried that yesterday. So those were all examples of proportional, and each one of those had absolutely that straight line that went through 0, 0. Well, we need to look at examples where they're not proportional. So I'm going to come back up here. And in your book, and now in front of your screen, we're going to take a look at page 47, and we're going to look at example number 2. So you still need your calculator. Pretty much everything that we do in chapter 1, you will use it. And let's look at this example as we go through and determine why, in this case, this one is not going to be proportional. So it says the cost of renting a video game from Games Incorporated is shown in the table. Determine whether the cost is proportional to the amount of games rented by graphing on the coordinate plane, and explain your reasoning. So over in this table here, you see video game rental rates and the number of games that are there and the cost for each one. So one way, when we first started lesson 4, we also talked about how we know if it's proportional in a table. You can always look at that first and always determine in the table, if you'd like to first, if it's a proportional relationship. So remember what we did. I'm just going to come over to the side here. I'm going to take these values from the table and just set up ratios. So I want to know, based on that first row, if it's going to be $3 for one game, is that going to be my unit rate? Is that going to be my pattern that goes through the table? Is that truly going to be $3 per game each time? Well, let's see. If I go to the second row, it's $5 for 2. Keep looking. $7 for 3 games. And then $9 for 4. So I just took the ratios out of the table. Let's take a look and see if they're equivalent. Well, $3 over 1 is still 3 over 1. $5 over 2. So if you were to divide 5 divided by 2, this one comes out as 2.5 over 1. So far it doesn't look good, right? They're not equivalent to each other. I'm just going to keep going. Okay. If I did the next 7 divided by 3, and you can divide these out at the same time I am, and you should be able to see this one actually comes out as a decimal at 2.3 repeating over 1. And then the last one, 9 divided by 4. This one comes out at 2.25 over 1. Nope. None of those ratios are equivalent to each other. So absolutely in the table, you can tell right away if you check that, it's non-proportional. Great. So what does that look like in the graph? So down here, these coordinate points from this table were graphed here on the coordinate plane. And so, even though you see on this graph that it's a straight line, remember, we have to make sure if it's proportional on the graph that it has to go through 0, 0. Is that going through 0, 0? Is that line graphed out from the data that we have in that table? Is that going through this point right here at 0, 0? It's not. No. And so even though you have a straight line, it's not meeting the other criteria to make it proportional. It's not going through 0. So this is a non-proportional, just going to underline right over here, non-proportional graph. And so the number of games rented is not proportional to the cost. Okay, so let's go right below it. Let's try here in letter B. So it says the table shows the number of calories an athlete burned per minute of exercise. Determine whether the number of calories burned is proportional to the number of minutes by graphing on the coordinate plane, and explain your reasoning. Okay, so right here we can take, and you know what? Let's do this first. Let's actually plot the points before we look at the table and try to determine from the table if it's proportional. Let's see if we can tell on the graph. So notice the way the graph is labeled. Time here is on the x-axis, and number of calories is your y-axis. So that means here, this first column is your x value, and that second column is y. So as coordinate points, this first one is 0, 0. The next one, 1, 4, 2, 8, and then 3, 13. So let's graph these. So I'm going to plot, let's see if I can get my dots to show up good here. So 0, 0 is going to be right there. 1, 4. So I'm going to go to the right, 1 minute, up 4. So my next coordinate point is going to go right there. 2 and 8 over 2 minutes, 8 calories right there. And then this last one, 3 minutes, 13 calories burned. So over 3, up 13. So it's going to fall right between 12 and 14, maybe about right there. Now, if you look, it may appear like it's straight. It's hard to tell. I mean, you could definitely take a straight edge and try to draw a straight edge through it and see if it connects into a straight line. It does go through 0, 0, but I would still come back and check the table. I would make sure that this table is proportional in case you're second guessing your graph right here. And so here's why. We come back here and let's look. So I'm going to take the table, I'm going to come over to the side, I'm going to take those ratios out of there, and I'm going to see if they're equivalent. So 4 calories, 1 minute, is that equivalent to 8 calories in 2 minutes? And is that equivalent to 13 calories in 3 minutes? Well, 4 over 1 is the same as 4 over 1. 8 over 2 is still the same as 4 over 1 simplified, so far so good. Now when I come to this last one here, 13 over 3, well, that's going to give me 4.3, and it repeats. Right here, this last ratio is not equivalent to the first two. If that would have been a 12, if that would have said 12 over 3, then yeah, guess what? It would actually be a proportional relationship. But because this ratio, this last piece of that table is off a little bit, they're not equivalent to each other. So right here in this section would not be a straight line. It's hard to tell, but it would actually curve a little bit right there. It wouldn't be perfectly straight. And so if, again, you second guess your plotted points on the graph and you're wondering, it could be straight, but it couldn't, it looks a little funny, then check the table. So this is considered a non-proportional relationship, non-prop. And if you're giving a reason why, an explanation, you can just say no equivalent ratios. Okay, so that was a little tricky, but again, you get to check two ways. You can definitely check in the graph and you can check in the table. Okay, so I'm going to come back up. I'm trying to, actually, no, I'm not. Let's go this way. So we're going to come down and I'm actually going to have you try number 1 here. So you're going to try this one on your own, and that is going to be on page 48. I'm going to pause the video. You're going to pause the video, and you're going to try this and graph it out and determine if you have a proportional relationship or not. So pause the video and try it. Okay, so let's take a look. So if the cost of 3D movie tickets is $12 for 1 ticket, $24 for 2, and $36 for 3, we're trying to determine if the cost of the tickets is proportional to the number of tickets. And you're doing that by graphing over here on that coordinate plane. So I set up a table. You didn't have to, but sometimes it's good to see it. And just showed that here, 1 ticket is 12, 2 is 24, 3 is 36. And I took those coordinate points and I came over to the graph and graphed those points. Now I did put 0, 0 here in the table because if you're not buying any tickets, 0 tickets are being bought, it doesn't cost you anything. So 0, 0 makes sense there. And then when I plotted the other points, 1 and 12, 2 and 24, 3 and 36, that is creating a straight line. I know it because I have a pattern of 12 every time. It's going by 12. 12 for 1 ticket, another $12, $24 for 2, add another 12 to that, it's 36 for 3. So it is proportional. My reasoning I put was it's a straight line and it goes through 0, and I can see that in the graph. Come right below that at number 2. The number of books 2 stores sell after 1, 2, and 3 days is shown. Which book sale represents a proportional relationship between time and books? So if you were looking at the Book Palace and you were looking at discount books, which of those 2 books right there, those 2 bookstores, has a proportional relationship just by viewing the graph right now? Think about that. Write down which one you think shows the proportional relationship and why. Pause the video. Okay, let's take a peek again. So if you look and knowing what we know about what makes a relationship proportional on a graph, we can see that the Book Palace has a straight line and goes through 0, 0. You should be able to also see on the graph, if you look at the Book Palace, why it's causing a straight line. It's causing a straight line because there is a pattern. So if you look, if it goes from 0 to 3, so 1 day is 3 books. It goes from 3 to 6. 2 days is 6 books. And it goes from 6 to 9. 3 days is 9 books. It has a pattern of 3 going through that graph. All right, so we're going to try one more. So you're going to go back to independent practice, and the other one that we did not do was number 1 on page 49. So now you're going to take number 1 and try this one. And you're going to pause the video, work it out, check your answer as soon as you're done. Okay, so let's wrap this one up together. I'm going to work it out so you can check your answer. So We've got weeks on the x-axis here. We've got the account balance, the dollar amount on the y. So if we were to graph these coordinate points, that means I'm looking at graphing 1 and 125 here. So I'm going to go over 1 week and up to 125. Change this really quick. So right here, if we then graph, the next corner point is going to be 150, 2 weeks, $150. And then at 3 weeks, there's going to be $175 in that account. So over 3 and up 175. Now, you're trying to determine if this is a proportional relationship. And so if you take a look right now on what you see on the graph, it looks like it's going to be a straight line. But what is the biggest problem with this right now? What do you notice right away based on what we've talked about? Is it going through 0, 0 here? No, it's not. And so if you were to think about extending this line out, so if you were to keep graphing points, is it ever going to go through 0, 0? No, it's not. It's never going to cross it there. So for that reason, you're looking at a non-proportional graph. And just visually, when you look at it, you know it's non-proportional because it does not go through the origin, or 0, 0. I keep using both of those words. It doesn't go through the origin or 0, 0. You know, the other way you could have checked is you could have looked at the ratios in the table to see if $125 in 1 week was going to be equivalent to $150 in 2 weeks, and if that was equivalent to $175 in 3 weeks. And it's not. It's not going to work out. So these end up being ratios that are also not equivalent to each other. Okay, so that's been a lot the last couple of days as far as looking at lesson 5 and really hammering some problems out and trying them and practicing them. And so thank you for listening, and thank you for taking your notes. You know that you can always use your notes, your book pages, what we've done in the videos, go back and look at those anytime when we're doing assignments. So tomorrow you will have an assignment. You'll come in tomorrow morning and you will see a quick check that you will have to do for lesson 4 and 5. So just realize by you following through and following with me and taking those notes, that'll be very beneficial for you as you go to do that assignment tomorrow morning. So take a look at the agenda, see what you have left to do for today, and I will see you tomorrow.